Well, Tesla just dropped a full self-driving demo today, and it's quite revealing. And speaking of full self-driving, Elon Musk thinks that full self-driving actually understands the world. Let's take a look. Hey y'all, it's Dr. Know-It-All. I was going to do a very different video today, but things happen. Tesla just posted this, so I thought, man, why not just go with this one and see what happens? And by the way, if you want a Cybertruck shirt, check out the merch store. Make sure you get yourself a Cybertruck shirt in advance of the Cybertruck delivery event, whenever that will be. I'm going to guess somewhere around a month from now or so, maybe a little bit more than that. Anyway, I doubt the October timeframe is going to work anymore. But on to the more positive end of things, Tesla full self-driving capability demo in Austin. I actually just realized I read that and I was very pleased with myself for realizing that it was in Austin, because I looked at some of the road signs and stuff and I was like, oh, they put it right at the beginning. So I should actually probably learn how to read. Anyway, full self-driving capability features use vision neural networks to perceive and understand the world, just like we humans do. Via our unique fleet learning approach, we are able to collect anonymized data from our vehicles, meaning the neural networks have learned from a few orders of magnitude more driving scenarios than the average human driver, including unusual and weird ones. I assume that means the unusual and weird scenarios, not the drivers. I don't know. Maybe they mean even us unusual and weird drivers. But anyway, the idea here is that we human drivers over a lifetime might drive maybe 1,000,000 miles. That seems like a pretty, substantial number of miles for a human to drive. If you even drove something like 20,000 miles a year, it would take you 50 years to drive 1,000,000 miles. So that's a lot of time. So most human drivers probably will not even reach 1,000,000 miles. Tesla, of course, is on the order of billions of miles captured, and even full self-driving miles is on the order of tens of millions at this point. So yeah, we're talking about at least an order of magnitude more than the average human driver, and possibly a couple of orders of magnitude more than the average human driver. All right, so let's take a look at this video, and it's 5 minutes and 10 seconds long. I don't know if I'll go through the whole thing or not. It's it's full self-driving video, and there's only so much you can comment. Of course, I will leave a link to all of this stuff in the description so you can check it out. Importantly here, the video shows current driving capabilities of full self-driving beta, which began deploying around 8/23/23, as software update version 11.4.7 or later. Currently, I believe the latest version is 11.4.7.2. Anyway, for demonstration purposes, the cabin camera driver monitoring remained active, but the hands-on steering wheel requirement was disabled. Customers cannot disable this feature. You'll notice the guy never touches this. All drivers must remain attentive and be ready to take over at any time. So they are specifically noting here that this is not, complete level 3 autonomy at this point. This is a demonstration. So I'm going to blow this up, but I also want to mention briefly that Austin is really important. If they had said this was in San Jose or Palo Alto or something, which is where Tesla's AI headquarters are, I wouldn't have been as impressed with the demo, primarily because California is the original testing bed for Tesla's software and Cruise, Waymo, a lot of other companies like that. So the San Francisco Bay Area, San Jose, Palo Alto, San Francisco, even though that's complicated, it's a relatively well understood problem. And so I think it's important for us to note here that we're looking at Austin, which is not traditionally as good as California. Now, of course, with Tesla being there more, obviously they're going to do a better job in the future with Austin and that area. But I just thought it was worth pointing this out because we're not talking about the best possible case for full self-driving. We're talking about a more average case. All right, so let's start it up. You can see that the driver here, if you don't know full self-driving, he is not going to keep his hands on the wheel at this point, but normally that would be the case with driving this car for legal reasons, but obviously, as they said, for demo reasons, they're not. I'm not playing the sound here, but the sound is just music. There's no actual talking or anything, so you're not really missing anything with the sound missing. Anyway, you can see that it's making an initial right turn. I honestly wish this is a Model S, I think it is because it's lower down. It could be a Model X, but anyway, I believe it's a Model S, but the problem is it's got that center console, which makes it nice to see the full self-driving capabilities right here, but it's also very, very dark and it doesn't show up well on this particular screen. So I think they would have been better served if they had used a Model 3 or Model Y with the large display over here that would have shown the full self-driving. Just a suggestion to the Tesla team that they should probably do that in the future because it's very difficult to see what's actually happening with the whole full self-driving thing right here. But of course, pausing here, you can see there's a little speed limit sign, which I believe is 25 here. And then also it's currently going 19 miles an hour and slowing down. So comes to a stop sign, slows down. Yeah, this is one of the problems is you just can't see. There's like a noodle that points to the right that shows where it's going. And this, of course, is the traffic, the navigation for it, the larger navigation screen. But anyway, I just feel like the demo would have been better if they had done it on a Model Y or something where you could have had the big white screen where it would have shown off a lot better. Anywho, you can still sort of see what's going on here. You can see the multi-lane road, and it actually moved into the center lane from the right lane, so it's going down the center lane. Also important to note, this is the current, consumer version of this. There is a version 12 back in August, I believe the 28th. He and Elon Musk and Ashok Elluswamy did a demo of the version 12 software, which is not really for it's not for consumer consumption yet. But anyway, they did a demo of that software, but that's not the consumer version. This very much is the consumer version of the software. And you can see it's driving very, very well. You can also see, of course, that they have pegged this at 40. They're not going faster than the speed limit, and they're being passed by everybody. So it's kind of the nature of the beast. When you're talking about actually doing real full self-driving, you have to go traffic flow. They're obviously, for demo purposes, trying to show off the fact that it does this, and it's a very official sort of deal. But any normal human is going to set full self-driving at 5 or 10 miles an hour, depending on the circumstances, faster than the speed limit for almost every town in the United States, at least, because nobody actually drives a speed limit. And here you can see it going from surface streets onto a highway. It's moving into traffic. I believe, what was that, 35? I don't know, whatever. It's a major interstate highway that goes into Austin. And then you can see the Austin skyline. You can also see that we're at 50x speed right now. So down here in the right-hand corner, you can see it switches over. So it's going like faster and slower so that you don't have incredibly boring, watching the video going. Anyway, it looks like what they did was they actually took a page out of Holmar's catalog, because he does this exact kind of drive where he just does these like sped up, slowed down. This is very nice. A little bit janky there. You can see the wheel turn. And actually, I'm just going to go ahead and rewind that just a little bit. So coming off the highway, watch, it has to get over. This is a Texas thing. You have to get over multiple lanes very, very quickly. And so watch the steering wheel. It goes like, and it has to get over pretty fast. Now, it is sped up 2.5 times, so I don't think it was quite as jerky as it might have looked, but that was multiple lanes it had to get over in traffic. So, if you're if you haven't driven this stuff and you don't know, for me, I'm like, yeah, this is regular things, but I have to realize that a lot of people don't understand how well this actually works. And this is driving itself. I mean, you can see the guy's feet, you can see the steering wheel, he's not touching anything. And it was able to get over multiple lanes coming off of a highway, figure all this stuff out. There's a yellow light that comes up, one of these lights that it comes through. I think it's the next one, maybe. Yep, right there. And so you can see it caught the yellow light changing to red and slowed down appropriately. And then you can also, of course, up here see all of the other vehicles and everything that it's going past. So it's a pretty effective demonstration of what's going on. I guess I'll go ahead and just let it finish playing out here. But anyway, so we're driving up through the middle of Austin. I have no idea where. They probably just dropped a pin someplace and decided that. And if you think that this was a carefully mapped out demonstration route or something where they pre-mapped it and figured out where everything was going, that's not the case at all. This is driving through neural networks. The likelihood is that they just dropped a pin. They were like, we want some place downtown Austin that will demo the car driving through traffic and stuff. And they just dropped the pin, and the car has driven them from maybe Giga, Texas. I'm not exactly sure where they started, but anyway, it drove them to this place, or is driving them to this place. But you can see the navigation up here on the right. It's going to make a right-hand turn, and then I think another right-hand turn to the end. And now we've gone from a faster speed limit to 30 miles per hour. And so it's making that turn, didn't stop, obviously, because that's the appropriate behavior. Now it's driving through multiple sections of cars, right, on either side. So it's understanding that and doing that appropriately. It's making a right-hand turn, another right-hand turn, and I think this is where it stops, right? So stop, that's it. And he touches it to put it into park and gets out of the car. So that's what's going on here. You can see at the beginning that to start it up, he swipes, I believe, here. Yeah, I use the stock. So, but anyway, it looks like what it was is it just requests you. Sorry, I haven't driven a Model S. So it's a little bit different interface, but basically it's like, yeah, do you want to do autopilot? And then you say, yes, you want to do autopilot. You respond to that, and that engages it. If you're driving a Model 3 or Model Y, you would double tap the stock and it would engage that. So all the way from there to the end of the video where he just gets out of the car by, going like, okay, I'm in park, I'm out of here. And that's about all you got. So in my opinion, this is a really, really good video for Tesla to post. They need to get the public to understand what the car is doing. The point of view was really good. I don't know what they did. They must have put a camera like right above the guy's head or something so that it was looking down from where the person is. My camera, I tend to put in the middle of the vehicle because it would be very inconvenient having a camera just sitting here when I'm filming videos. But anyway, you can see all of that stuff works very well. Again, I would personally suggest that they use a Model Y or Model 3 in the future and maybe move the camera over to the middle and set it low so that you can see the center screen right here is where the navigation is. The reason why is just because you can make it much, much bigger. This is a relatively small display, which is not available on the Model Y and Model 3, and it's also black, and it makes it really, really hard to see what's going on. Whereas this display, you can set it not satellite mode, but you can set it to like a map mode, like a Google map mode, and then it's very, very clear what's going on, and you can expand the full self-driving to take up the entire screen, so you can really see what's going on much better. But anyway, big kudos to Tesla for doing this. I think this was needed. It's the kind of thing where a lot of the general public doesn't know what's going on, and this is exactly the kind of informative video that can really help people get a taste for how well this stuff is working, and it is working exceptionally well. And that brings us around to Alex Kerr's recent post, Does ChatGPT Understand the World? This is what Ilya Sutskever, co-founder of OpenAI, says during a discussion with Jensen Huang, CEO of Nvidia. So if you want to have two of the biggest heavy hitters in the AI space, you would pick one of the co-founders of OpenAI and also the CEO of Nvidia. So this is a pretty heavy hitter discussion. And of course, you can see the video down here. I'm not going to play the video because the text actually incorporates what was in there, but you should definitely check it out. I will leave a link to that, of course, in the description. So Ilya says, when we train a large neural network to accurately predict the next word in lots of different texts from the internet, the AI is learning a world model. On the surface, it might look like some learning correlations in text, but it turns out that to, quote, just learn statistical correlations in text, to compress information really well, what the neural network learns is some representation of the process that produced the text. This text is a projection of the world. What the neural network is learning is aspects of the world, of people, of the human conditions, their hopes, dreams, motivations, their interactions, the situations we are in. The neural network learns a compressed, abstract, usable representation. And then Alex asks, do you think learning representations equals understanding? Are large language models simply stochastic parrots, or are they much more? And then if you think, what does this have to do with Tesla? Well, Elon Musk responded to this conversation and said, yes, end-to-end full self-driving is the same. And if you want to check out all the responses to Elon underneath it, there's a lot of people who agree and a lot who disagree. Interesting conversation after the fact, but I just wanted to stick with what Ilya said and what Elon responded to it. So moving back to Alex's post, this is an interesting thing. Are large language models simply stochastic parrots? A parrot, if you don't know, I actually had a parrot for a while until my dog killed my parrot. It's very, very sad. But anyway, it was an African gray. He learned a lot of words and he would parrot things back to you, right? And really in very accurate voices and things like that. And so the idea here is a stochastic parrot. Stochastic is kind of random reality, it's real world randomness. So it randomly picks a word and parrots it back to you. And then the question is, are they much more? Well, I'm going to start with the statement, and I know this for a fact, that my parrot understood what was going on. It wasn't just saying random words and stuff. It was putting them in the proper places and responding to me and doing it in ways that indicated that he understood what was happening in the world. It was a fascinating experience. And, again, very tragic that he died and only, I think he was 12 years old. So he wasn't all that old yet, but he had learned a lot of stuff, including things like when I would be on the telephone, he would, of course, answer the phone and say hello. You could say, yeah, that's easy stuff, right? The phone rings and he says hello. But he would also understand when I was about to hang up. And it wasn't when I said, goodbye or something. It was before that. He would, like, just a second or two before I was going to say goodbye myself, he'd say, okay, bye. And that's kind of the way I usually end my phone calls and everything. But it was bizarre because it was like he was listening to the conversation. He was quiet. He wasn't talking, but he was listening to the conversation and he would somehow understand that it was about to wrap up. I don't to this day know how he knew that, but he would know the phone conversation was about to wrap up and say, okay, bye, about a second before I would. And it just just blew my mind every time. That's just one example that I'm remembering. There were many, many examples of this. But to denigrate this by saying stochastic parrot actually denigrates what parrots do, because I think parrots understand the world way better than we give them credit for. But regardless of your feelings about that, this is kind of the crux of the whole thing, this highlighted part. To compress information really well, what the neural network learns is some representation of the process that produced the text. And just today I was watching a news thing with Sabina Hassenfelder. She does a bunch of news on weekdays, and I believe it was her thing. I listened to a bunch of stuff as I'm driving around and working out and stuff. I'm pretty sure it was her video. But anyway, she had a thing that showed that large language models, if you feed them a whole bunch of geographical information, basically you ask it about geographical information and then you look at its information about that. And I'm not exactly sure how they did this, but basically you can map it out on a kind of a two-dimensional Mercator projection of the world, and it will actually put those things into the right places. It kind of has an understanding of geography and where things are related to each other just from listening to language. In other words, this is something that doesn't have access to pictures of globes. It doesn't have access to things like this, like a globe in the background. It doesn't have that. It just has language, and yet it's able to create kind of a notion of where things are spatially and just the idea of space itself. So there's a lot of information clearly that's buried in human text and human speech. We probably don't adequately realize it because, of course, we do have vision as well. So most of us are able to take in information in a visual sense too. So I think we tend to lower the amount of information that's in text, just the way we think about it. I don't know because I haven't done any research, but I imagine that people who are blind are able to get a sense of geography and stuff from text. They don't have the benefit of seeing things and figuring out where things are visually. So there's this idea that they have to be able to create this spatial awareness through language and, of course, through their other senses and interaction with the world. So it does seem to be a possibility that you can do this, and it's really fascinating if it turns out that large language models actually do have a sense of spatial awareness, even though they've only been exposed to language. So that's one representation of the world. Spatial, how things are related to each other, the distances apart, where they are, north, south, east, west, all of that kind of stuff is a representation. That's one representation. There are other ones, of course, too. There's emotional representations. There are content representations, like what are you saying? There's the denotation, like what is the thing that you're saying? And then there's the connotation. What do you really mean by that? Sentiment analysis, things like that. So clearly large language models are able to also model that kind of a thing. And that then is a representation of the process that produced the text. And it also is a form of compression. And that's why he says to compress information really well. What you're doing, what humans do, what animals do to a lesser extent, what large language models are doing as well, is compressing a very complex reality that has infinite numbers of variations and stuff into a much, much smaller model than that so that we can interact with that world. If you dealt with everything all the time, it didn't just go like, that's a tree, that's a, grass, a lawn or something. If you didn't just kind of like take in and then ignore most 99% probably of the stuff that's happening to you every day, you would be non-functional. So what we're doing is we're creating a world model, clearly human beings are, and in order to create that world model, we have to compress the world down into something that's not the world. It's a representation of the world. And that's the argument that Ilya here is making, is that we're getting that kind of compression. These things are compressing the world into much, much smaller containers than the entire world. And even if you just take language by itself and you don't deal with the whole natural world around you, we've got something that's multiple gigabytes that's compressed down trillions and trillions of words in all sorts of languages. So it's taken something much, much bigger and it's squished it down into a much, much smaller format. And then it's able to reproduce that information as you ask it. And that is really profound. It's doing something very, very similar to what humans do. And it's learned on its own. We've given it the neural network architecture. We've said, here's your architecture. This is what you're allowed to learn in. Now learn. And it's figured this stuff out and it's used that architecture, very clever human architecture that we've created, but it's used that architecture to compress the world into some sort of representation. And that representation, Ilya at least, and I also think represents some level of understanding of the world. And that's what he ends up with down here. The neural network learns a compressed, abstract, usable representation. Now, of course, Ilya is talking specifically about large language models and text, but Elon Musk, of course, chimed in and said end-to-end full self-driving is the same. So he's talking about version 12 of the software, to be clear. That's the end-to-end, fully end-to-end. Although personally, I think that 11.7.4.2 is pretty close to end-to-end. It behaves differently than the earlier versions of 11.4 did previously. So anyway, I think even the consumer version is getting pretty darn close. But the end-to-end software is photons in, it's the world coming in, and out comes a decision about how to drive. And remember when I said text was not a full representation of the world? Well, the other half of that representation is vision and interacting with the world. And so what we're getting from full self-driving is the complement to large language models. You've got, on the one end, you've got human, consciousness as poured into text and just put down on pieces of paper or, electronically, whatever. Anyway, you've got that put down in already kind of an abstracted, convenient model. It's actually much easier for a large language model to learn because language itself is already a compression of reality. We're not spitting out sounds of the way things are in the real world. We're talking in abstractions to each other. We're like, oh, did you see that pine tree over there? Well, you have to compress that knowledge down into what is a pine tree, and then the other person has to understand that knowledge, and then they can look over and they can see it, and then they can agree with you or not and say, no, that's an oak tree, you dummy, whatever that thing is. But that sort of thing is already compressed. Reality, what the car is receiving is really real. That's the photons, that's the things coming in from the real world that we all have to deal with. So it's a more complex reality than language is already, just by the fact that it's not being moderated through human language. And so what I'm getting around to here is that Elon Musk is understating the case here by saying end-to-end full self-driving is the same. I don't believe that. I think end-to-end full self-driving is actually an order of magnitude more complex, more compression that's happening because it's dealing with the real world, not with already abstracted ideas that humans have given these large language models. And you've probably heard me say on this channel before, if you've listened to many of my videos, that I very strongly believe that full self-driving or some sort of autonomous driving type of software or robotics, taking Optimus, which is going to be even more complex because it has to interact with the world in addition to just understanding it. Anyway, I believe that that is the path to artificial general intelligence more quickly than large language models. I think that humans won't recognize it because we won't understand because we're not talking to it. Large language models have a really, really big leg up in terms of making humans think that it's really smart because it can respond to us the way that a human being would. A car can't do that. It can drive. So, that's not the most enjoyable thing. It's something that we just do, but in order to drive, it has to have an immense understanding of the world. And so my prediction is that full self-driving autonomy, again, including Optimus, the robot, is heading more quickly to an AGI, an artificial general intelligence, than large language models are. We're just being tricked because LLMs are dealing with language. And so we hear them and we think that they are more clever than full self-driving or robotics, autonomous robotics are, but that system is actually a deeper understanding of the world. And hey, guess what? These two things are not mutually exclusive either. You can meld these together, and I believe that Tesla is working on this themselves. I know for a fact that Google is because they've got their robot that they have trained up with text and video information from the internet, and their RT1, RT2, and RTX robots are actually making significant progress by blending robotics and movement and things like that together with text. And I'm sure that Tesla is working on the same thing from clues that I've heard about that. And what that means is it's not just doing the full self-driving / robotics autonomy in a bubble. They're actually blending large language model aspects into the code, into the basic architecture of full self-driving. So I don't know that we'll see it in the car because it's not super necessary for the car to do this, but I am strongly of the opinion that Optimus will have a very, very deeply integrated language model into itself so that you're able to have a discussion with it. You can go in while it's making dinner for you and have a discussion about Hobbes or something, the philosopher, or Calvin and Hobbes or the cartoon, whatever. You can talk about something like that while the robot is making dinner because it's able to operate on multiple levels, including linguistic and physical action. And of course, once they get that for the robot, there's no reason not to backfill that to your car. So again, your car can be driving you someplace and you could have a really interesting conversational companion as well. So in general, I agree with Ilya. I see that you have to compress the world world. You have to reduce it, the complexity of it and everything, to create a model, to create an understanding of what the world is. And that understanding is much deeper than just what, the parroting things back again, even though, again, I disagree with parroting because I think parrots are much smarter than people think they are. But anyway, I very much agree that you do have to have a model, and that model has to represent reality, and that representation of reality represents some level of intelligence. And that Tesla's full self-driving / autonomy is working very hard towards the same thing and doing it in a much more complex, unregulated environment. It's open-ended, right? Reality is very open-ended, whereas language is much, much more constrained than that. And so again, I'll repeat, I believe that Tesla is going to get to artificial general intelligence faster than a company like OpenAI. So, all right, we've gone from a drive in a full self-driving vehicle that Tesla posted all the way to artificial general intelligence and Tesla's autonomy versus OpenAI versus Google and other companies. Super interesting stuff. I hope you agree. And if you do, please do like the video so other people can find it. And of course, consider subscribing for more of this kind of content. As always, a huge shout out to my patrons on Patreon, my YouTube channel members, and of course, my ex-subscribers. Thank you all so much for supporting the channel in any way that you can. And of course, if you want to join any of the teams, just check out the links in the description. And if you're interested in a whole bunch of really cool merch, check out our merch store. Link is in the description. We have TeslaBot t-shirts, the Tesla meme t-shirt, success is a possible outcome, 4680 battery cells. All of that stuff is on t-shirts, mugs, tumblers, and on and on. So check it out. And finally, don't forget we are both Tesla and Amazon affiliates. If you look in the description, you can see how going shopping for a new Tesla, a solar roof, a power wall, or anything on Amazon helps out the channel. In the meantime, I'll see you in the next one. Bye-bye.